Welcome back to another episode of Innovations in Technology. I'm so glad you're with me today. I'm Mike Konrad. I'll be your host for this episode. The complexity within the electronics industry is at historic highs within all segments of the electronics industry, and perhaps that is what is creating a greater need for inspection in all aspects of the electronics industry. Which brings me to my guest today. My guest today is Dr. Subodh Kulkarni. He is the director of CyberOptics since 2009. He's been the president and CEO since 2014, in addition to his past roles as lead director and executive chairman. Dr. Kulkarni has held several management positions at Prism Computational Sciences, iMation, 3M, and IBM, and he's also serving on the board of directors of Keytronic. Dr. Kulkarni received his Bachelor's of Science degree in Chemical Engineering from the Indian Institute of Technology in India, and went on to obtain a Master's and a PhD in Chemical Engineering from MIT. He's won a number of awards for commercializing technologies that he and others have developed within the electronics industry. Today, he's all ours as he joins me for our conversation about his current venture, maybe adventure is a better word, with CyberOptics. Dr. Kulkarni, welcome to Innovations in Technology. So glad you're my guest today.
Thank you, Mike. Thank you for the opportunity.
Of course. Let's start off talking about CyberOptics, since that's your current gig right now, and you've been there quite some time in various capacities. How long has CyberOptics been around? When did it start? What types of products do you produce? What kind of markets do you sell to?
Sure. So CyberOptics has been around since 1984. It was founded by Professor Steve Case from the University of Minnesota, and that's why we are still headquartered in the Twin Cities in Minnesota. He and his graduate students started the company when lasers were relatively new, and they were looking at applications to do detection and inspection using lasers at that time. The company focused on laser-based inspection for the first decade or so, and then eventually they got more vertical, doing inline solder-based inspection and inline automated optical inspection since early 2000s. Lately, the focus has been on two technology platforms that we are investing in and have pioneered. One is 3D non-contact optical sensing technology that we call MRS, that stands for multi-reflection suppression. And another technology that we have pioneered is what we call wafer-sense, that is in situ detection in a wafer or a reticle form factor. The company is fundamentally a sensor technology company, developing innovative sensors for two vertical markets, SMT, which stands for surface mount technology or electronics, and semiconductors. Even though they are related, they do operate as two distinct market segments. So again, CyberOptics is basically a sensor technology company coming up with innovative solutions for SMT and semiconductor markets.
Yeah, excellent. I always look at the semiconductor market as a crystal ball to what's coming toward the electronics market. It seems to be a precursor. If semi's high, business is coming our way. If semi suffers, hold on, right? Fasten your seatbelt. How did you get into this industry? You've got a pretty wide experience serving with other companies, all within kind of the high-tech industry. So what brought you to CyberOptics, and what's your background?
I mean, my love and fascination for the semiconductor industry started actually in grad school when I was at MIT. My PhD thesis was silicon surfaces. So I was looking at literally the fundamentals of epitaxial deposition of silicon. That took me to IBM. I was a fab engineer for a while, working on CVD and plasma etching processes. And over time, I've always been in and around the semiconductor industry for the last 30 plus years. What got me into CyberOptics, first as a board member, is my know-how about optical technologies. And I had the fortune to meet the founder of CyberOptics, a terrific guy. Unfortunately, he passed away some years ago. But he is the one who got me involved with CyberOptics. He was looking for a board member with a technical background, and I was available to be a board member at that time. Once I became a board member, and saw the technologies being developed inside the lab. When the company had the opportunity to have a new CEO because the previous CEO wanted to retire, I did think hard about taking this job. And because of the technologies, I decided to come in the company, even though it was a much smaller company than my previous experiences. The technologies were too exciting to turn down the offer, if you will. And I have loved every minute of it. I mean, we have essentially worked on commercializing the two technologies that were very attractive to me. And we are penetrating both the semiconductor as well as SMT markets with our two technologies with differentiated products. And really, at the heart of it, our technologies enable better ROI for our customers in terms of yield, productivity improvement. And that's really what we are up to. We are commercializing new innovative products in semi and SMT to help our customers.
Excellent. I feel like I've come full circle. The word optics obviously is in your company name, CyberOptics. One of my past guests was Dr. Eric Fossum, who was the inventor of the CMOS image sensor way back in the day. So to talk to the inventor of digital image technology and then talk to someone who has exploited that technology for the benefit of the electronics industry and taken it kind of to its limits is it feels like a very full circle event. Now, I know that you didn't found, you weren't the founder of CyberOptics, but I'm sure that you probably have an answer to this. When companies get started, they either get started because they want to just pile on, they want to be also run kind of companies, and they just go, well, if they can do it, we can do it too. Or they see something missing in the industry that no other company has been able to address. I'm assuming CyberOptics is the latter. What was missing from the inspection industry that created a need for CyberOptics to fill that need?
I mean, over time, things have changed, obviously. When the company was founded, and again, I was not involved, I was still in college, in my college days in the early 80s. So when the company was founded, I can clearly see that lasers were new. They were literally coming off the shelf, if you will, as a technology in early 80s. And electronics assembly was becoming more and more robotically driven. So things were, many pick and place companies were beginning to launch uh, these robotically handled assembly lines. And there was a need for fast inspection to keep up with the robotic speeds. Human eyes were no longer sufficient to be the inspection criteria. So lasers were a natural solution that Steve and many other people at the same time. I mean, if you think about it, Cognex was founded around a similar time period, and many other companies too. And I believe they must be all thinking along the same lines where lasers were a terrific tool, if you will, that they had available suddenly. And it had the speed, it had the accuracy to meet some of these robotic placement inspection requirements. So that's the way the company started. Obviously, over time, things have changed quite a bit. Um, Lasers have given way to the more what was laser triangulation, and it still remains a good part of 3D inspection technology. There are many applications that can be well served with laser triangulation even today, but over time, parts got smaller and they continue to get very, very small. Assembly boards, if you look at it, assembly board today versus what it was 10 years ago, and certainly what it was 30 and 40 years ago, it looks dramatically different. Flexible substrates started coming in. And most recently, in the last 5 years or so, semiconductor technology has taken a drastic step towards stacking. I mean, it's almost like the third dimension got invented for the architects of semiconductor technology.
Right.
I can just imagine what the early architects in the 1900s went through when they suddenly discovered that they can put skyscrapers together, and all the freedom that it unleashed and all the creativity it unleashed. And to some extent, that's what's going on in the semiconductor industry right now. Suddenly, they can stack multiple chips on top of each other, in addition to the stacking that's happening in the NAND technology. And now all kinds of creative packaging solutions are being unleashed. And essentially, it's giving us this modern improvements. I mean, if you look at our smartphone today versus what it was 5 years ago, and certainly what it was a decade ago, I mean, there's a day and night difference in the performance and bandwidth and all kinds of performance aspects. And at the heart of all of it is the hardware improvement that many of us are responsible for, and semiconductor technology and electronics being two of the drivers of this improvement. So it's almost a little renovation, if you will, in creativity. So for 40, 50 years, the semiconductor industry had become, I don't get me wrong, I mean, it was doing its job in shrinking the transistor and it kept shrinking the transistor per the Moore's law at a nice clip. Maybe in the last decade, Moore's law slowed down a little bit. Instead of 18 months, it became 27 or maybe even 36 months. But then came the third dimension, and now suddenly things are looking very different, very rosy. So everyone's projecting now that in the next 10 years, this improvements that we have been seeing in the last decade will continue. If anything, they will accelerate. So it's going to be a fun decade for semiconductors and electronics, coming along with all kinds of creative solutions being deployed.
Yeah, kind of like a new country discovered. All of a sudden, they can build up rather than out. We're no longer in a two-dimensional world. I remember back talking about inspection technology. I entered into the electronics industry in 1985, and we all at that time witnessed the evolution, or probably revolution, of surface mount technology. And I remember when BGAs first came out, there was a huge cry for, how do we look under these things? This is before X-ray was utilized for that purpose. And there were these oblique angle viewers that would basically using mirrors to kind of look under the BGA. That was as close to it as we can get. And of course, when you look from the side under a BGA with a mirrored camera or microscope, all you see is the first few rows of balls. Who knows what's behind that? But there were all these fancy, very expensive optical devices, and it wasn't until in the early days, anyway, X-ray came along that we can actually see into it. In fact, I always joke. We've talked about this on other shows and other episodes that my belief is X-ray causes voiding, because before X-ray, there were no voids, under a BJ. But I'm sure that's the same in your industry too. You're showing your customers things they didn't know they had in terms of problems or the quality or integrity of a solder joint or a wire bond or whatever it is that you're testing. You're in multiple markets within the electronics industry. People think of electronics, if they're civilians outside our industry, they think electronics is basically computers, and that's it, right? And but obviously there are many facets and many segments within the electronics industry, and you're in multiple markets, and each one of those markets, I would imagine, have very different dynamics at play. So talk to me a little bit about the major market dynamics that you currently see at play within the different market segments that you're supporting.
Yeah, I mean, that's a very good question, Mike. Indeed, electronics market gets lumped in together, but there are many facets within the electronics market. Probably the drivers continue to be a smartphone. I mean, smartphones have done a really good job of driving the electronics market over the last decade, and will be one of the drivers for the next decade or so. And that's because of the complexity of electronics that smartphones use, the density, the stacking stuff I talked about, and many other innovations that are coming along. Smartphones are driving a lot of them. Auto has become a big driver of electronics of recent. I mean, if you look at a EV car, it's practically chips on wheels right now. Um, and that is driving a lot of demanding applications, because auto electronics tends to use much higher currents than smartphone boards, for obvious reasons. I mean, we are driving batteries and real wheels and stuff like that, so they do need higher power, and that changes the complexity of electronics and what is involved and what is not involved. There are many other areas or interesting areas of electronics that are pioneering the whole area too. I mean, one of the areas that we got involved a few years ago and is a big driver of our current business is mini LED backlights for display screens. I mean, right now the display screens are either LCD or OLED technologies, and both have their pros and cons. And out comes mini LED backlight with the LCD filter in front of it that seems to have the best of both worlds. It still has a few drawbacks, but it seems to have the best of conventional LCD and conventional OLED. And that makes the display look dramatically better and consumes a lot less power. And right now, that is a single uh, consumption of power in your smartphone, if you will. So just imagine not having to worry about charging your smartphone for a few days. Some would say even for a few hours. So lot of fun little facets within the electronics areas, but they do drive. But I would still say smartphone, auto, and other things like mini LED, which are unique applications. Memory industry continues to be another driver of electronics. I mean, if you look at what memory industry is going through and the staggering rate at which they are advancing the chip technology right now, but behind the chip, there are many other things that electronics industry has to keep up with for making sure the memory boards are working okay. So there are many other drivers too. Medical devices has been a good driver of late again, because these are devices that actually end up in the human body. So they have to be FDA approved or other regulatory agency approved. And unlike other electronic items, you don't want to get reoperated once every year or once every 2 years.
Yeah, it's
So
not like
this give
changing a
us,
battery, right? Yeah, you
no,
don't.
exactly.
Yeah,
So once you put a part in the body, I mean, the patient and the doctors are expecting that part to be there pretty much for the lifetime of the patient. And that puts severe constraints on electronics, the battery technology, and all others. So, very different areas that are driving electronics right now. But certainly, I would still highlight smartphones, auto, medical devices probably are the three, and memory probably are the main drivers right now.
yeah, and I think all of that is being at least partially driven, if not entirely, by Internet of Things, by IoT, or
Absolutely.
our huge appetite as a society to surround ourselves with connected devices. And these electronics may be class one; they may not be life or death, high reliability electronics, but when we buy something, even if it's a connected toothbrush, we do expect it to last. And in that example, these parts are going into what I would arguably harsh environments, and
Mhm.
therefore are subjected to the same factors that could kill a more safety critical
Mhm.
application. So it appears that we are applying inspection techniques and the importance of good inspection to way more than just high reliability devices, classic class three space type, devices.
Mhm.
I think IoT is driving, it's pulling that technology down to its level in terms of being able to produce a product that just functions, not necessarily life death, but certainly to support the reputation of the manufacturer. Even if the manufacturer is Mattel or Hasbro, it still matters.
I mean, one good example is lately, if you look at the cost of a silicon wafer, by the time it reaches the end of its processes in the front end area, the cost can approach as high as $100,000 per 300 millimeter wafer. So every wafer lost is a huge loss for the entire production ecosystem, if you will. So it's imperative for the manufacturers to make sure they minimize losses when the cost of each of the chips is so high. And that's where inspection comes in. I mean, you could live without inspection, and that's what many people did. I mean, they were relying on human eyeballs as inspections for centuries, right? I mean, that's how manufacturing and the whole world used to work with. I mean, the whole concept of inspection, and certainly optical and laser based or pattern light based inspection or X-ray inspection, as you brought up, this is all, most of it is in the last 30, 40 years. And one of the reasons is because the parts are, as parts get complex, you cannot afford to have those losses. You cannot afford to throw even a single silicon wafer anymore if the cost is $100,000 or something like that. So you're right. The end product may be a simple Barbie doll from Mattel or some other product, but if in the process you have to incur tremendous losses, you just can't do that. And that's where most sophisticated manufacturers right now take put inspection at various points in the production workflow, right from the starting point to the final product. And that's how yields are as high as they are, productivity is as high as it is. And there's no stopping there. I mean, right now, as you mentioned, IoT is a big driver, but AI has come along in a long, long way in the last decade. And now we are expecting robots to be running factories. I mean, if you go to the most recent 3 nanometer node semiconductor fab, and I was there before the pandemic in one of those places in Korea. It's a little spooky to enter a factory that is running full gear, and there's no lights. Wherever you go, lights turn on. And finally, you almost have to ask, is the factory running? And then they say, yeah, but why have lights? There are no human beings in the factory. The entire factory is being run by robots right now. And that's the future of production. I mean, this is just a little insight into how future factories are going to look. But those future factories will need inspection. I mean, robots are terrific, but they do need periodic feedback on where they are, what the part is supposed to be. If something is not going right, how do you get it back to normal, if you will? So that is the future of automated production. AI is going to play a huge role, and that's how we are going to bring costs down and complexity in our production.
Yeah, evolution always starts with a buzzword, and the buzzword is lights out factories. Now, it's
Without factory is a
obviously
buzzword.
that's a buzzword, but it has a basis in reality in the fab world, as you're saying.
I have
It's
seen one, and it
Yeah,
is a little spooky to enter a
yes,
lights
it's
out
so
factory.
hard to imagine in other applications and other segments of the electronics industry. The assembly side, for example, how we can have lights out. But then again, I'm sure 10 years ago, if I had told you that the fab shops would be lights out, you would go, yeah, not really. That's crazy. But
Exactly. Yeah.
so it happens. And for all those people who are worried about losing their jobs, don't worry. Someone has to build all those robots. And ultimately they're going to be factories well lit, to create the environment where we can have lights out factories.
Hmm.
So in business, if your business isn't facing challenges, then you're probably not a very innovative business. And I can only imagine that CyberOptics has faced challenges over the years. My business every business faces challenges,
Hmm.
and the survivors dominate, and those that
Hmm.
don't. So tell me what types of challenges that each of your market segments face. Let's start with semi, then we'll kind of get into SMT and then more specific products like printer cartridges and mini LEDs and things like that.
I mean, you're right about the fact that every business has its challenges, and the markets we serve, and including our own track record, shows that we have seen plenty of challenges over our history, and we'll continue to see them. So, starting with semi, I mean, the challenges we touched on it earlier. You absolutely have to do these advanced processes like stacking. EUV has been a huge challenge. EUV being extreme UV lithography. Uh, it was supposed to be in full production by now. It's just starting to get there. So on the front end side, EUV deployment has been a massive challenge for the industry. On the back end or mid end side, stacking, all these various advanced packaging technologies that are being deployed right now, to for because it's driven by the performance needs, create a massive amount of challenge for people who are putting these processes together and controlling the processes. And that leads to challenges for companies like us who have to design inspection equipment to monitor those processes and make sure we are giving accurate feedback so the processes can be dialed in for perfection. So there's massive challenges in the kind of technologies that are being deployed in both front and back end, along with people like us who have to inspect those processes and provide continuous feedback. Uh, Probably the biggest challenge, as I said, on the front end is EUV, on the back end is probably stacking, but there's plenty of other challenges that are driving the semiconductor industry. Not to mention, and this is getting headline news all over the world right now. I mean, chips are in severe short supply, as you can see, just about in every daily news right now. Um, and the cost to put a new fab is as high as 15 to 20 billion dollars, and it even if you had the money, it takes you 2 to 3 years from the day you make the decision to get to your production in a decent form with decent yield and decent productivity. So it's a long time span. It's an expensive business proposal, and not too many places in the world can afford to invest that kind of money. And that's why you see uh, governments, including our government here, getting involved now, because chips are the heart of many things in the future, including national security related devices. And suddenly the awakening has come to some extent that if you want to control your future, you do need to control your own chip technology, if you will. And so you're seeing more investments being dialed in right now in different parts of the world, including US, and that is a challenge by itself. I mean, it's not trivial. Financial industry loves some businesses where the ROI is obvious, where you say, I invest X and I'll deliver X plus 10% or 20% next year or 2 years from now, even though they like to say they are long-term oriented. In the chip world, in the semi world, we are dealing with really long-term horizons. I mean, the ROI has to be done on a 5 year or 10 year or even a 20-year basis, not a 1 or 2 year or 3 year. And that, unfortunately, the chip industry to some extent has suffered because of that, and that is a challenge. I mean, if you go to the financial world, investor world, and that's where money gets for capitalism, we need to go there to get money. They have historically not been good for the chip industry. If you notice, they have been very reluctant to loan money to semiconductor companies because they see long time horizons, they see cyclicalities in the marketplace, and those are all challenges. So as an industry, we have many challenges. I would say there are technical challenges, there are financial challenges, there are policy challenges at a government level to convince them how they should be doing investments in this kinds of industry. So hopefully that answered a little bit of your question on the kind of challenges at a semiconductor industry level we are seeing.
Yeah, I think in the semi world, if you make a decision to open a new foundry, you're probably going through one or two economic cycles before you produce your first chip out the other
Absolutely.
side, right? So,
Yeah.
yeah, I can see why investors stay away. What about the surface mount world, the actual electronic assembly world? Any unique challenges there?
Yeah, again, the semiconductor industry gets closely coupled with the electronics industry, as you said earlier. And even though they are different industries, they are definitely linked. So some of the challenges in the semiconductor industry flow to the SMT side, although there are differences. I mean, clearly, it doesn't take that kind of investment to put SMT lines together as it takes for a foundry, if you will. But at the same time, um, some of the challenges, like I mentioned, advanced packaging challenges that are happening in the back end area right now with stacking, fan in, fan out, those kinds of processes. Um, they are creating significant challenges for the SMT industry. What was a conventional PCB with discrete devices and chips, where you could see most of the things either with optical technologies or with X-ray technologies, are no longer sufficient. I mean, this stacking creates unique structures, these heterogeneous materials that are being used create unique challenges both for optical as well as X-ray or whatever, even E-beam kind of stuff that is being used sometimes. And we need to be inspecting very difficult kind of parts and try to make sense out of those inspections and provide our job at the end of the day is to improve our customers' yield and productivity. And so we have to give them valuable feedback so that they can control their processes better. And if it is difficult to look at the data because of the structures, it just makes our job extremely hard right now. And just like any other part of the economic cycle, SMT industry has its own ROI to worry about. I mean, the lines are getting expensive clearly with all these complicated parts, whether it's a pick and place machine or an inspection machine. Um, it wasn't too long ago that you could actually put an SMT line together for a couple $1 million, if you will. Now, with the complexities and in the structures and all the peripheral equipment that goes on the line, you are talking 2 or 3 times that price tag today than what used to be a decade ago. So it is becoming a challenge for the SMT industry to invest in those kinds of lines to make sure that they can meet their customers' requirements. But that's where the industry has moved and will continue to move. I don't think there's ever going back to what used to be the situation. I mean, flex circuits are here, advanced packages are here to stay, and those things are not going back. They are just going to get more and more complex as we go forward. So certainly, there's a lot of challenges in the SMT industry today, and they will continue to grow. But they are different than the semiconductor industry challenges.
Yeah, I think the cost of a surface mount line, as you said, certainly has risen, but it only is expensive if we only look at that. If we compare it to the semi world, it's cheap. $20
But you have
billion
to keep in
to open
mind,
a semi plant, and 2 or 3 million to put a surface mount line in seems like a bargain.
fair enough, but you have to remember that for every foundry that's cranking wafers out there, you need thousands of SMT lines to keep up with that
That's true.
foundry.
That very true.
So
So maybe
when you multiply, then it's comparable.
right. Yeah, that's true. Maybe even more expensive. So why is this? This sounds like a rudimentary question, but I just want to I want to provoke you into talking about inspection in terms of its importance. So the rudimentary question is why is inspection so important? When I began my career in the MS space back in 1985, inspection largely consisted of a microscope, 1530x magnification. We talked about those oblique viewers when BGAs first came on the scene. Do we inspect because the technology exists, or does the technology exist because we have an increased need for inspection? What's driving the need for all this?
I'm absolutely sure it's the latter, okay, which is the technologies have always been around, but inspection gets implemented only because there is a need. I mean, nobody, whether it's a semiconductor customer or a SMT customer, says, I want to implement inspection technology because this brand new technology exists. I mean, inspection at the end of the day is a tax on their productivity. Okay, it's going to cost you something to implement inspection, and more inline inspection, more the cost. That just goes without saying, because you are buying equipment, you have to have some labor associated. Even though most of the stuff is automated, you still need some labor involved periodically. So there's a cost to injecting inspection in anything. At the same time, so they are doing an ROI on what is the cost of not injecting inspection. And if obviously the ROI is good, they implement inspection and they implement inline inspection, and that's where people like us step in. So invariably, we never get called in because we have a new shiny object that they love. We get called in because their processes are complex. They are having a tough time controlling the processes. Their yield is a problem or their productivity is a problem, and they need inspection to help them with those problems. That's invariably the way we get pulled into the picture. And that's been the way for a few years, and I suspect that will continue to be the way. The one thing that has changed is, as you mentioned, what used to be a simple microscope or a metrology lab in the corner somewhere where you periodically took your part to make sure everything was okay. The attitude has changed quite a bit, given the complexity of the products and the processes. People, sophisticated manufacturers, I would say, accept the fact that you are going to need inline inspection. You do need periodic feedback to maximize your productivity and yield. So people are much more open to talk about what the inline inspection needs are today than what it used to be several years ago, and certainly several decades ago.
Excellent. Switching subjects, there's a term that CyberOptics use. I don't know if it's a cyber optic term or if it's an industry term that I'm just ignorant of, but hero products. That would be your SQ platform, WX platform, things like that. How does CyberOptics address the needs within those particular products line? And tell me what hero products means.
I believe the term is generically used in industry, certainly in companies that are developing some kind of gadgets, if you will. So most companies have their, maybe their word may be different internally, but the concept is the same. I mean, it is the key products that are driving your current results and will continue to drive your results for the next 2 to 3 years. That's the way we are using it. So in our domain right now, the two or three key hero products, if you will. One is the SQ3000 multifunctional system. It can do SPI, it can do AOI, but it can also do CMM, coordinate measuring machine. So we can do the same machine with a flip of a software switch, can go from a solder paste inspection to an automated optical inspection to a coordinate measuring machine. And that is a key product that is driving our current financials and will continue to drive our financials for the next 3 to 5 years. Another one is MX3000, which is our memory module inspection system that is being used by both DRAM and NAND manufacturers right now as a final vision inspection, that is driving their yields and productivity right now. WX3000 is a new one that we just launched. It will be a hero product in the future, but as of today, we are still demoing it to many customers. That's a wafer level inspection for things like bumps and pillars and stuff like that. But we have other hero products in our wafer sense category, like the auto resistance sensor and the internal particle sensor, IPS is what we call it. That's an inline in situ particle monitoring product, so it can go in pumping systems of EUV lithographic systems, if you will, in the front end of semiconductor fabs, and continuously monitor the particle count, and it bins the particles in different buckets, and it is reporting the real particle count. So right now what happens without that product is, if there is a particle surge, your EUV system goes down, and then you have to flush it with argon or nitrogen, and that can take several hours. And these are extremely expensive systems. I mean, the cost of a typical EUV system is $130 million a piece right now. And so even a few hours of downtime can be catastrophic for the manufacturer. So our IPS product is essentially monitoring and letting them know that the particle count is drifting so they can do periodic flushes. So you avoid a several hours downtime by having a couple minutes of flush every X hours. So that's a huge value to them. So those are some of the key products that are driving our results. But I like to view them in technology buckets. Maybe it's my technical background that makes me think along those lines. So I view that most of the products that we are selling today that are driving our results fit into what we call the MRS bucket, the multi-reflection suppression, 3D sensing technology we use. So they are all tied with the kind of sensor we use. Uh, and the other is the wafer sense bucket, which is where we are doing this in situ diagnostics by choosing extremely small sensors and coupling it with lithium ion battery and a Wi-Fi or a Bluetooth element to make them capable of doing in situ diagnostics. So the two buckets, MRS and wafer sense, are really the hero categories, if you will, for us, and will continue to be for the foreseeable future.
Interesting. So let's switch again and talk about I don't know, pandemics, shall we? No one saw that coming, and clearly, if you were investing in a fab business, 2 months before March of 2020, that hit everyone by surprise, particularly that industry, every industry for that matter. So how has CyberOptics been doing relative to the pandemic? I'm sure that travel kind of came to a stop. I don't know if travel is a big part of your model, but how has the pandemic affected CyberOptics, and how have you managed to trudge through all of the challenges that a once in 100-year global pandemic can bring?
And overall, we have done very well to manage through the pandemic. And starting with the employees, I mean, it's been a challenge for just about every company that has people, obviously, where you have to follow the protocols as carefully as you can. I mean, we have two big areas where we have people. One is the Twin Cities here, right here in Minnesota. Another is Singapore. Um, we are fortunate. I mean, our governments have done a reasonably good job both in Minnesota as well as in Singapore. So policies like masking and social distancing were generally practiced fairly quickly in our local population, and we have followed the local laws and protocols, and we try to do over and above what the local leaderships are telling us. So we have been very careful with how we have managed our employees. I mean, our factories have been running nonstop throughout this period, and we have had a few COVID cases, unfortunately, but we have kept them down to just that you can count on hand because of the policies that are in place. So we have been fortunate in how we have been able to respond to that COVID disease in that sense. On the business front, actually, we have done very well. I mean, part of it is, and maybe some are arguing that COVID didn't really change anything per se, but it accelerated trends in technology. So things that were already happening, whether it was IoT or 5G or cloud or many of the stuff that we talked earlier about, was already in place and it was shifting towards that anyway. But COVID pulled in a lot of that stuff, and partly because many of us, instead of traveling, we started working from home. We needed better bandwidth at home. We needed better gadgets at home. Most of us have replicated our office setup at home right now. So a year ago or a year and a half ago, my home had some basic stuff that I could use to function remote. But right now, my home is pretty much a replica of my office. I mean, whether it's got all the stuff that I have in my office, and clearly that meant buying a lot of gadgets and bandwidth and stuff like that. And I'm not an exception, I believe. I think many of us have done the same, and that has driven extremely high demand for semiconductor chips. So overall, if you say what has COVID done to the industry, I would argue that COVID has grown the semiconductor industry and demand, and that has followed now into electronics. So budgets that were being spent on discretionary things like travel and stuff like that are coming towards this industry, to our industry. So if anything, I mean, I cannot imagine semicap is going to post. Semicap posted a good growth last year, about 15%, I believe, was the final number for semicap in 2020. And you look at the global economy that declined in 2020 because of COVID, and many sectors in the economy, like retail and airlines and so on, got hammered pretty bad. But here's in that climate, semicap actually posted a 15% growth, right? I mean, that's very unusual. And I think COVID may have shifted the dollars towards semi to some extent. And it's continuing. I mean, 2021, when the books are closed, I won't be surprised if semicap shows 20 plus percent and maybe even a 25 plus percent growth. So time will tell exactly how different industries got impacted by COVID, but I'm pretty sure um, semiconductor and electronics has overall benefited because of some of the things that the pandemic has done to
Yeah,
us.
I completely agree. We manufacture capital equipment for the assembly space, and yeah, it's been a very good year. I mean, we've been very blessed, and it's tragic how certain segments of the market, you mentioned airlines, hospitality, things like that, were just decimated, and other industries, blossomed as a result of the pandemic. I think one of the takeaways is, as a business owner, looking back at the chart of accounts, which I like to do at least once a year, and in seeing, historically travel, and then 2020 travel, it's like no travel expenses. Yet we still manage to communicate with customers. We still manage to provide service. We still manage to provide training. We still manage to produce educational content,
Mhm.
and we didn't have to sit on an airplane and in a stinky car in a dirty hotel room, eating food bad for your health at the local restaurant. We were able to maintain a pretty high quality of life at home with our families, and we didn't skip a beat. So I think there's going to be a lesson after the pandemic for every company that, is all that travel really necessary? Is every trade show really necessary? Does every symposium have to be in person? I think the genie is the genie of the freedom from travel is out of the bottle, and I don't think she's going back in.
I agree with you. I mean, things have changed, and I don't think we. I mean, people say that when will the pre-pandemic days? When are they coming back? And I don't think they'll be back in some form or shape, but it won't be exactly the same. I think many of us have gotten used to a new norm now, and
Yes.
some of the things are actually good about it, right? I mean,
Yeah.
there is a real value in not having to travel. And sit in congested flights and taxis and all the stuff
All
you
the
mentioned.
all the road warrior stuff. Yes, exactly.
Yeah, and I think airlines are seeing exactly that. I believe they are seeing the consumer back for personal travel, but they are not seeing business travel pick up again.
Yeah.
And many of them are afraid now that that's not coming back for at least 3 or 4 years. So I think similar stuff is happening in many other industries. Some for good.
Yeah, many for good. I mean, as much tragedy as there is, and none of these advantages are worth one human life. There are definite silver linings from this pandemic, and I think the biggest thing that companies have learned, and I'm sure you're among those, is when employees stay home, they actually get work done. There are, everyone was always concerned about all the inefficiencies of being home. Taking care of the dog, getting the mail, watching TV, whatever distracts you. But it turns out there's probably more distractions at the office place, within a cubicle environment as people are walking by, coffee breaks and chit chat and all that stuff. It turns out you get a lot of stuff done at home when you're not surrounded by a bunch of coworkers, right?
No, I mean we have been blessed to be having all the devices that we have again around us to enable that stuff. I mean the first time, most of our systems when they're complex, you need to send an engineer or two for install and training and stuff like that. So when the pandemic started, we went remote as you can imagine. So we were shipping the systems, but our engineers were virtually helping install and training. And I thought it was not going to work, but not only did it work, but now customers love it because they can literally be anywhere, and the engineer can be in any other part of the world, and we take over the system through internet linkages and all that, and it becomes so much more efficient than actually necessarily standing next to the person and trying to drive the mouse when both of them can drive off the same virtual screen and stuff like that. So if anything, it has improved the quality of installation and training than what it used to be, which
Yes.
was a little eye opener for myself that
Yeah.
this kind
Yeah.
of modern tools are actually really, really good.
Yeah. I totally agree. Let's wrap up with this with this question. Reach into your back pocket, pull out your Subodh Kulkarni crystal ball, and let's see your fortune telling skills. What's the outlook for the future? Not just within the inspection industry, the electronic semi industry in general, and what's next in the cyber optics world that you can talk about?
Well, I am an optimist by nature. You need to be to be in our industry and high tech world, because there are many years that things don't look that good, and you have to go through them, plow through them. So I'm an optimist. I do believe semi and electronics are well poised for the next decade or so. And I'm not the only one saying that. There are many other people saying that as well. But there are some real genuine factual data points to support that statement. You look at how much the industry has grown this year or last year, and will expectations for growth are continuing for the next 3 to 5 years at least, and maybe the next decade or so. So I'm very optimistic about the whole industry in general. Certainly, when it comes to cyber optics, where I have more control, we are very optimistic about our future. We actually have outdone the market for the last 5 years or so. If you look at our actual financials, we have done better than what semi and electronics as a whole have done this year. Last year, we grew about 18%. This year, analysts are expecting us to grow about 30% or so. Next year, we don't put out forward guidance, but what clearly, given the backdrop of the industry, we expect us to continue to grow profitably for the next decade or so. So I feel very good about how, as a company, we have done financially. But financial is just one part of it. I look at the morale of employees. I look at our employee headcount, the diversity among employees. I believe we are firing on multiple cylinders at the same time. So our headcount is increasing, our diversity is increasing. I feel we are better integrated with our broader society at large, if you will, and moving in the right direction as not only as the whole semi-electronics industry, but certainly as a company. So I'm very optimistic about the next few years here.
Excellent. You know, there's people who are not in business don't understand this, but growth is challenging. Growth has a unique set of challenges, probably even greater than negative growth. You know, if a company is contracting, its cash flow actually gets a little better, right? Because they're not
Usually it does,
reinvesting
yeah.
all that cash,
Yes.
you know, into growth. And growth is, I find, extremely challenging, particularly too much growth. So to be able to, in a pandemic environment, to manage a double-digit growth really says a lot about the company and the leadership of that company. And that is, as I said earlier, just a unique challenge on its own. So anything new coming out of CyberOptics? You don't have to get into too much specificity, but you know, are there new avenues? Are there new market segments that you're looking to get into?
We always look at getting into new market areas and where we could take our technologies. For the foreseeable future, expect us to continue to innovate in the two technology buckets that we already are well established, the MRS and the wafer sense area. Continue to expect us to innovate and come up with new technologies and products within those two buckets. Again, primarily servicing the semi and electronics markets. Right now, as you correctly pointed out, we are going through double-digit growth for a few years now, and we expect that to continue. And it is a challenge. I mean, it's a challenge I'm gladly embracing. I would
It's a
rather
good
have that
challenge.
challenge
Yes.
than other
Yes.
challenges of negative growth. But it is a challenge. Working capital is always a challenge. You have to watch out for double-digit growth because it creates its own set of issues. So, to be honest, we look at acquisition. We have plenty of cash on our balance sheet as a company. We look at acquisition opportunities. We look at getting into new vertical markets. But I'm refraining from doing either of that just because we are experiencing solid double-digit growth in the two markets we are in. And we don't want to mis-execute and miss those opportunities. So for the foreseeable future, expect us to continue to focus and invest heavily in MRS and wafer sense for semi and electronics. And if there's a good opportunity that comes along the way, we will obviously take a look at it, but that's not what we are counting on.
Very good. Dr. Subodh Kulkarni, CEO, CyberOptics, thank you so much for being my guest today. I really appreciate your time.
Thank you, Mike. I appreciate the opportunity.
My pleasure.